So today we'll be talking about Citizens Broadband Radio Service, abbreviated as CBRS. My name is Isabella. I'm currently a senior at Olin, and I use she, her pronouns.
I'm Lauren. I use she, they pronouns. I'm a junior at Olin. So what is CBRS? So basically CBRS is a 150 megahertz band that ranges from 3.55 to 3.7 gigahertz. And it is shared by the users of three different priority levels, which include incumbents that include the fixed satellite service, radio location service, and AV system, and priority the priority access license that include the private institutions and hospitals and universities. And lastly, the general authorized access that include the cell phones and home routers, etc. So here's a more specific or more detailed frequency allocation spectrum, and so we can see that CBRS is shared with FSS state earth stations and aeronautical radio navigation, and that is in addition to its upper band, which is FSS telemetry, and it's the lower adjacent band, which is radio location. Now we're going to introduce the in-band coexistence issues. So how does SAS work? So basically SAS stands for Spectrum Access System. It is a database and some algorithms that manage the coexistence within CBRS. And so firstly, it creates an exclusion zone where incumbents use are detected, and then it communicates with the CBRS devices, which also is denoted as CBSDs, to communicate and coordinate the allocations. So while the incumbents uses of the CBRS is protected, SAS also ensures that the FCC rules cannot be violated while maximizing the use of commercial systems.
So you saw on the last slide something called ESC, which stands for Environmental Sensing Capability. And this is a network of sensors that's located along both coasts of the United States that is used to detect when the naval radar system needs to use a portion of the spectrum. The main challenge with this is that the sensors have difficulty detecting when there's interference from other devices. So with the sensors, there are two classes of CBRSD devices. The Class A, which is the small indoor devices, and Class B, which are the outdoor larger base stations. And so Class A devices must maintain at least a 40-kilometer distance from the ESC sensors in order to not cause interference. And the Class B devices need to maintain at least an 80-kilometer distance in order to maintain no interference. In addition, the FSS earth stations require a similar distance in order to minimize the interference. So from both Class A and Class B devices, they need to maintain a 150-kilometer distance from the FSS earth station. And so these are called coastal exclusion zones and protection zones, respectively. So in July of 2020, the FCC held Auction 105, which is where they auctioned off 10 megahertz sections of this band to the priority access licenses. So that was like the hospitals or universities, different private organizations. And they auctioned off about 7 PALs per county. Any one giant communication giant could hold up to 4. And this accumulated $4.6 billion from companies like Dish, Verizon, and Charter. So after the auction, popularity for this band really increased, and companies were looking to deploy this along the more densely populated areas of the coast. But as we just saw in the diagram for ESC, all of the sensors are located along the coast, and they still need to maintain that 40 or 80-kilometer distance from the sensors. And so this kind of creates a dead zone around each of those centers where the CBRS band cannot be deployed. And so we have a couple proposed solutions for that. The first and most obvious probably is decreasing the area that the coastal exclusion zones need to be. So instead of being 40 or 80 kilometers, decreasing that size down. The main caveat with this is that the technology hasn't been fully developed or research, and is pretty far from being implemented. So that might take a little while and is not quite the most useful for the present. The second option is incumbent informing capability, which is where the Navy would directly inform when they are using their system so that they can turn off the other like cellular systems and give that Navy priority. Some caveats with this is that it would introduce some security risks because they would be directly saying when they're using the radar. In addition, this system, as it currently is laid out, uses a manual input and maintenance, and so that adds the factor of human error, which could end up being detrimental if there was ever an error.
Yeah, so that was all about in-band coexistence issues. Now we're moving to adjacent band. So basically, SAS sets the limitations, or it sets the instructions on how to operate the lower band to those licensees at 3.45 gigahertz bands to avoid the interferences. Also, it sets limitations on the nearby power of operation. Next slide, please. So, like now we're talking about how the 5G technology would eventually affect CBRS. This is a spectrum of the 5G and CBRS. I know currently 5G is not applied to CBRS. Well, like because the CBRS system is mostly developed in 4G LTE, so we're not going to fully replace that with 5G technology. But the 3.5 gigahertz band will still be the first mid-band that will deploy 5G built on the current 4G system. We need to make sure that the flexibility is enough to support the future technologies for like 5G and 6G in the future. So yeah, that is all.